In today's episode, we delve into a series of groundbreaking developments in space exploration, including a mysterious spectral presence reported on the Moon, the preparations for Athena's lunar landing, and an unexpected Gremlin making its debut in the SpaceX Starship. For the first time in over 50 years, an American-made spacecraft has achieved a safe and successful touchdown on the lunar surface, marking a new era of lunar exploration led by private companies in collaboration with NASA. The Blue Ghost lander, developed by Firefly Aerospace in Cedar Park, Texas, is at the forefront of this new wave of lunar missions. Funded by NASA under their Commercial Lunar Payload Services (CLPS) program, Blue Ghost represents a significant step forward in commercial space exploration. The mission carries 10 state-of-the-art scientific payloads, each designed to conduct experiments and gather data that will enhance our understanding of the Moon's surface, subsurface, and environment. On March 2nd, Blue Ghost began its final descent to the lunar surface, culminating a journey that began over a month earlier. Launched in early January aboard a SpaceX Falcon 9 rocket, the lander spent 25 days in Earth's orbit performing rigorous system checks to ensure all components were functioning correctly. Afterward, it embarked on a 4-day transit to lunar orbit, where it spent an additional 16 days meticulously identifying the optimal landing site. This careful approach highlights the complexity and precision required for modern lunar missions. Blue Ghost's target landing site was the Mare Crisium region, a vast lunar mare located on the Moon's northeastern near side. During its descent, the lander relied on an advanced AI-powered computer vision system to navigate the terrain. This system, which operates in fully autonomous mode during the powered descent phase, analyzed the surface in real time, identifying hazards such as craters, slopes, and rocks to select the safest landing spot. Firefly Aerospace has proudly declared itself the first commercial company to achieve a fully successful moon landing, though they acknowledge the earlier attempt by Intuitive Machines, which resulted in a hard landing and limited mission success. The scientific payloads aboard Blue Ghost are already hard at work. One of the most intriguing instruments is the Lunar PlanetVac, a vacuum system designed to collect regolith samples from beneath the lander. These samples will provide valuable insights into the composition and properties of lunar soil. Another fascinating experiment is the stereo cameras for lunar plume surface studies, which captured high-resolution images of the dust plume generated by the lander's thrusters during touchdown. This data will help scientists understand how lunar dust behaves in the Moon's low-gravity, airless environment, a critical concern for future missions, as excessive dust could pose risks to equipment and astronauts. To address the challenge of lunar dust, Blue Ghost is equipped with an electrodynamic dust shield, a revolutionary technology that uses electrical currents to repel dust particles. This innovation could prove invaluable for protecting solar panels, windows, and even astronauts' visors during lunar exploration. Another key instrument is the next-generation lunar reflector, which will enable precise measurements of the distance between Earth and the Moon using laser beams. This reflector will contribute to ongoing research in lunar science and geodesy. The mission also includes a drill called the Lunar Instrument for Subsurface Thermal Exploration, which will penetrate 2 to 3 meters into the lunar surface to study heat flow and thermal properties. This data will help scientists understand how heat is conducted through the Moon's subsurface, providing insights into its geological history and evolution. Additionally, the lunar magnetometer, mounted on a mast extending from the lander, will measure magnetic activity deep within the lunar mantle, offering clues about the moon's internal structure. After 14 Earth days of operation, Blue Ghost will capture images of the lunar sunset, documenting how the regolith reacts to changing light conditions. The lander will continue to function for several hours in darkness until its batteries are depleted, marking the end of its mission. This data will provide valuable information about the moon's thermal properties and how its surface responds to temperature fluctuations. Meanwhile, Intuitive Machines is preparing for another lunar landing attempt with their Nova-C lander named Athena. Scheduled to touch down on the moon's south pole, Athena carries a suite of advanced instruments designed to explore this scientifically intriguing region. One of the key payloads is the Trident drill, developed by Honeybee Robotics, which will penetrate up to 1 meter below the surface to collect soil samples. These samples will be analyzed by a mass spectrometer called M-SOLO, which will detect the chemical composition of the soil, including the presence of water and other volatiles. Athena will also deploy a small rover named MAP, developed by Lunar Outpost, to explore the lunar surface and create detailed 3D maps. This rover, which is less than 2 feet in length and height, weighs between 5 and 10 kilograms and can carry up to 15 kilograms of payload. MAP is equipped with a near-field depth camera that will generate high-resolution 3D scans of the lunar surface, providing valuable data for future missions. Riding on the back of MAP is a secondary micro-rover called AstroAnt, developed by MIT. This tiny rover, small enough to fit in the palm of your hand, is designed to test swarm robotics concepts for future spacecraft diagnostics and repairs. In addition to these payloads, Athena will deploy a rocket-powered miniaturized lander called Micronova, developed by Intuitive Machines. This small hopper vehicle, measuring just 2.5 cubic feet, can carry 1 kilogram of payload over distances of up to 2.5 kilometers. Micronova is designed to explore hard-to-reach areas such as permanently shadowed craters and subsurface lava tubes where water ice is believed to exist. Equipped with high-resolution cameras and a spectrometer, Micronova will provide valuable data about these unexplored regions. In SpaceX news, the highly anticipated Starship launch was postponed due to technical issues. Elon Musk explained that concerns over ground spin start pressure led to the decision to delay the launch. The mission has been rescheduled, and Musk has emphasized the importance of achieving full reusability of the Starship before conducting in-flight refueling tests. This milestone is critical for the future of space exploration, as it will enable more efficient and cost-effective missions to the Moon, Mars, and beyond. Musk also revealed that the long-awaited in-flight refueling test, originally planned for 2025, has been postponed to next year. This test, which involves 2 Starship upper stages docking in low Earth orbit and transferring cryogenic propellant, is a key step toward enabling long-duration missions to deep space. However, Musk stressed that full reusability of the Starship must be achieved first, as this will significantly reduce the cost of space travel and make ambitious missions more feasible. As we look to the future, these missions represent a new chapter in space exploration, driven by collaboration between government agencies and private companies. The success of Blue Ghost and the upcoming Athena mission demonstrate the potential of commercial lunar exploration, while SpaceX's Starship program promises to revolutionize space travel. Together, these efforts are paving the way for humanity's return to the moon and beyond, unlocking new possibilities for scientific discovery and exploration.